Hello, everyone, and welcome to the Esri GeoDev webinar series. We began these webinars as a continuation of the discussions and presentations of developer-related topics between Dev Summits. We wanted to keep the conversations going, and we hope you get as much or more out of it than you anticipated today. Now, we would like to introduce you to today's webinar, Real-Time GIS Mapping and Analytics. All right, Morakot, let's get started with the webinar, shall we?
Yes, thank you, Amy. So, hi, everyone. My name is Morakot Piluk. I am a senior software developer and consultant on the real-time GeoEvent team, big data team. I've been with Esri since 1996, so it's been 22 years working here. So with me today is Ken Gordon. Ken, please say hello to everyone and introduce yourself.
Hey, good morning or afternoon, everyone. Ken Gorton here. I'm a product engineer on the real-time and big data teams.
All right, let's jump into what we're going to cover today. So first, we will provide a short overview of GeoEvent Server, just to bring everybody up to date on the Esri real-time technologies. Then we will share with you some information and statistics on where these have been adopted, which provides some ideas for you on where are the development opportunities. Then we'll show you how to set up the backend environment to enable the real-time workflows. This is to support your front-end real-time application development projects. After that, we'll cover how to interface your applications front-end to the back-end. And lastly, we'll show you some of the sample applications and some useful information. Right, let's jump right in. So first, I'd like to tell you what is GeoEvent Server. So it is a Esri real-time GIS technologies. It's not exactly new because it evolved from ArcView 3X time, which was around the year 1998. It was under the product name tracking. So they're tracking server and tracking analyst on the desktop. Tracking services, backend server side product. It was implemented in C and C++ COM technologies back then, and release cover from version 8.x to 10.1. So 10.1 was the last release for tracking under the name tracking product. So we completely rewrite the code in Java in 2010 and get the product under the name GeoEvent Server. The first release was in 10.2, which was around 2010 or 2011. The current release is 10.6, and we're going to release 10.6.1 soon. So it is a real-time data gateway for ArcGIS applications, and you can also use for other applications as well, if you would. It is a back-end server-side component. It doesn't have a desktop applications or front-end that show you visualization of real-time data. So let's have a look at the architecture side of Esri real-time technologies. So on the diagram here, you see on the right, GeoEvent Server, Spatial Temporal Big Data Store, which part of the ArcGIS Enterprise umbrella. And outside of that, we have the application level on the web device or desktop that will interface with the ArcGIS Enterprise. So GeoEvent Server, which is the purple box on the lower left corner, can do many things. First, it can ingest high-velocity real-time data into ArcGIS. The data may be coming from aircraft, ship transponders, vehicle GPS devices, smartphones, and other sensors like traffic sensor, environmental sensors, etc. Once real-time data reaches GeoEvent Server, the data will be analyzed by the real-time analytics components of ArcGIS Server. You can design your own real-time processing logics, which you will see in Ken's demos later. The real-time processing is normally designed for detecting some patterns of interest. For example, vehicle entering or leaving the job site, water pressure in the pipe rising above or defy threshold, and you can detect many other things. The detection results from the real-time analytics will lead to some sort of triggers. This will cause alert to send out to notify someone as emails, SMS messages. Both alerts of data itself can be logged or recorded in the backend data stores. So you see the data store on, which is the orange box on the lower right corner. So this can be traditional relational data, but it may not be suited as real-time data store due to limitation in writing rate. So the relational traditionally will only retain about a few hundred events per second, where data might be coming in more than thousands events per second. And as the hardware technologies become better and more affordable, more sensors are being deployed and being, sent at a better transmission rate. So the rate are not better; it's going to be more and more. It can reach 10,000 in the near future. The incoming data are growing beyond 1,000 events per second. So this demand better data store technologies. We added a spatial temporal big data store into the ArcGIS Enterprise architecture, which will help because it supports writing rate of tens of thousands events per second. We will look into the big data store in the more detail in the next slide. So here's some more technical details about the big data store. So it is based on Elasticsearch technology, which is built on top of Lucene. This technology is being used by large social media like Twitter. The big data store can be scaled out by forming a mini cluster. This can be done by adding more nodes to the configuration, which enable fail-safe, failover, auto-replication, auto-recovery, and load balancing. It implemented very fast spatial index using GeoHash, which is quad-tree-like structure, make it qualify to be a real-time data store, with the writing rate reaching tens of thousands of events per second and the retrieval rate of millions of features in just a few seconds. And this also leads to another challenge in visualizing that large amount of data in a very short time, especially on a map. In a zoom-in view, there may be just a small number of features to be rendered. So you can display a discrete feature, in this case, no problem. But when you zoom out, in a zoom-out view, there could be millions of features to be rendered on the map. And imagine they're also moving around, right? And this may no longer make sense if you have millions of things to display on your map. If you render a discrete feature, it just fills up your screen. The big data store offers a solution by performing aggregated rendering on the server side. This is done really quickly. The result is heat map-like aggregated maps, so you can aggregate it on count or on some statistic on a specific attribute columns. This is configurable. And it also provides automatic transition between aggregated and discrete rendering based on number of features in the map extent. To support spatial temporal analytics, real-time data has to be stored and accumulated over time, which can become really large. In many cases, number of records of feature can reach 400 or 500 million in less than a week. You can imagine if you were dealing with social media like Twitter, there are 30 million tweets a day or more now. So if you record that to the database, right, you can imagine how quick that could grow. So many organizations also want to keep the data around for several months or years. In Singapore, they want to keep it for 15 years. So we have to deploy some storage strategy here to keep things running, right? Otherwise, it just fill the disk and system can crash just because of that. We have to use some sort of retention policy to trim down the data. It's also a good idea to move the older data to the secondary or cold storage if you want to keep them around. So another important part of the real time is how you retrieve data to display or to analyze on the application side. So two typical patterns that we offer are by using feature layers, which is polling or retrieving of record from database. And another one is polling, pushing, sorry, it's by stream layers, right? So traditional way of retrieving data is by feature service or map service, which offered by traditional geo database or even the new spatial temporal big data. They're the same pattern here. The difference is retrieving from traditional geodatabase will be much slower and has a lot of latency, while retrieving from spatial temporal big data can give you millions of records in just a few seconds. But that can overwhelm the front-end application really quickly to deal with large amount of data like that. Another way that you can overcome this by choose to use the streaming service from GeoEvent Server. This is a publish subscribe patterns that application subscribe to stream service, and GeoEvent will just push data incrementally when it received from the sensor or the data source, and then it will just show up on your application side, bypassing all the database layers. So I like to share with you about some statistics here. What is your opportunity in developing with S3 real-time technologies? So since the first release of version 10.2 around the year 2010, 2011, GeoEvent Server has been adopted by more than 1,200 organizations in 87 countries around the world. The user base covers many sectors: commercial, defense, intel, public safety, transportation, state, local, and national governments, electric, gas, water utilities, nonprofit, educational, natural resources like oil and gas, big oil companies using GeoEvent as well, health and human services like hospitals. I've involved in consulting and implementing of many of those myself. Some recent examples are like Boston Marathon to track runners, ambulance, police vehicles. Last year, American Red Cross tracks and monitored their emergency response vehicle during the Hurricane Harvey and Irma. So to support some of those applications, let's take a look at what our application stack look like. So on the back-end side, we need to have GeoEvent Server, ArcGIS Server, and ArcGIS Data Store. And it would be good to have ArcGIS Portal as well to manage who can access what features, layers or map layers, right? On the front end, some of these you don't need to even write any code. For example, you can put together very focused application using Operation Dashboard, which are available now with the JavaScript versions. You don't even need to install anything, just log on to ArcGIS Online and look at the web map and then say create dashboard from web map. You can also use Web App Builder and App Studios. If those three cannot meet the requirements, you can choose to program it yourself using some of these languages: iOS, Swift, Xamarin, Objective-C, Qt, JavaScript, Android, Windows. You can choose any one of those. Today, we will focus mostly on JavaScript. The nice thing about using ArcGIS Runtime SDK is the SDK, the APIs are very much similar across the board. They might be leaping in front of each other in one or two releases, but you learn one API, you can easily adapt to another programming language. So today, Ken will show you mostly JavaScript. So I like to hand it over to Ken.
All right, great. Thanks, Morcott. Thank you, Morcott. So yeah, as Morcott mentioned, we can go ahead and develop applications using real-time data, but in order to be able to do that, we need some real-time data. So at first, I'm going to walk us through setting up a real-time workflow in GeoEvent Server. And in order to do that, we need to take a look at, we need to take care of three broad tasks first. And two of those involve moving the data into and out of the server. And in both of those cases, we need to understand something about the data and its location, where it's either coming from when it's coming into GeoEvent Server, or where it's being sent out to on the other end. So we need to understand where that is and how it's going to make that transition, and also what the format of the data is. Is it JSON? Is it XML? And so forth. Now, once we have the inputs and outputs defined, and data is flowing through GeoEvent Server, we have the additional opportunity to set up certain analytics using processors and filters to interrogate the data and maybe modify the data or throttle its volume, the amount of data flowing through the server. So let's take a look at each one of those in a little bit more detail, starting with input connectors. Now, the role of an input connector is to translate incoming streams of data into discrete messages called GeoEvents. And the connector is going to, the connector that you choose to use to bring data in is going to be entirely dependent on where the data resides outside of the server and what format it's in. So we have a connector, for example, that will watch a folder for new files, and those files might be JSON or CSV or what have you. We can also set up connectors to pull external websites for JSON or XML or the data that is there. And each of these connectors pairs that transport mechanism with a parser or an adapter so that we can bring the data in from a specific kind of location and then translate that data into a GeoEvent. We have a number of out-of-the-box connectors that would apply to a wide variety, a huge majority of cases. But then we also have a number of connectors they're not out of the box, but they're available in the Esri gallery that are for far more specific types of applications, such as bringing GPS data in using the NMEA connector, or bringing common alerting protocols, such as public safety announcements like you might get from the Weather Service about storms and so forth. That's a very specific XML type of format. We also have a number of partners who write their own connectors, such as Verizon provides their network fleet connector so that you can fleet managers can connect their vehicles to GeoEvent Server. And a lot of people use the Waze connector to bring traffic data into GeoEvent Server as well. And if in the event that none of these connectors meet your needs, you can also write your own. We provide a Java SDK with GeoEvent Server that allows you to write your own components. Now, once the data are in GeoEvent Server, we can set up one or more analytic steps, processing nodes within the server to act on each one of these GeoEvents. The processors that are available out of the box do things like, they might modify attributes of the GeoEvent message or make some changes to the geometry. They might calculate values. For example, the field calculator does that very thing and allows you to modify or insert new values into any one of the fields that is a part of the current GeoEvent. Additional processors are available for download from the gallery, and this allows you to expand the processing capabilities of your GeoEvent server. Now, I'd like to point out that most of the processors are stateless, and that is that once they act on a GeoEvent and send it along to downstream processing or to an output connector, it forgets about it. It doesn't maintain any sort of a history or knowledge of previous GeoEvents, but certain processors are different. They are stateful. And they maintain a history of previous GeoEvents so that they can use that information to perform some pertinent action. And a great example of that is the motion calculator available for download. It calculates certain motion statistics for GeoEvents as they move through GeoEvent Server for moving objects on the ground, things like average speed and acceleration and so forth. And the only way it can do that is if it knows what that vehicle reported as its speed in previous observations, so that it can use all of the accumulated information to calculate an average speed for the current GeoEvent observation. And as with input connectors, if the processors that are available don't quite fit the bill, you can always write your own using the SDK. And then finally, output connectors. Very similar to input connectors, they are entirely dependent on the type of data format that needs to go out and the destination that it needs to go to. You might choose an output connector to send an email, which is obviously fits a very different need than writing Esri features into a feature service. But we have a number of connectors that are already available that you can use and configure for your own output requirements. And just as with input connectors and processors, there's a number out of the box, but some additional ones that are available for download from the gallery, such as connectors that allow you to write into big data repositories like Hadoop or MongoDB, or to send actuation commands to Amazon IoT or Azure IoT hubs. And of course, you can write your own using the SDK. But before you jump into writing your own input connectors, it could be that you can configure a new connector without having to write any code. All of the existing connectors that are part of GeoEvent Server out of the box are simply combinations of existing transport and adapter components. And so if, while there's no receive GeoJSON on a TCP socket that comes with GeoEvent Server out of the box, there is a TCP transport and a GeoJSON adapter, and you can couple those together to make your own new input connector if you require that combination of transport and adapter. Likewise, you might download the Kafka component from the gallery and use that as the transport along with a featured JSON adapter to configure a new connector that you can use for an input. But if you do go the route of developing your own components, remember you can write your own input or output connectors as well as processors. And you do that with the SDK, and the SDK will be installed automatically when you install GeoEvent Server. And you find that we're in the same folder and directory where GeoEvent Server is installed, and that's by default typically C program files, ArcGIS. And in the server and GeoEvent folder, you find the SDK folder down there with API documentation. That there's Java doc that is associated with the SDK, as well as a local Maven repository, and then a bunch of sample connectors and processors that you can use to follow through that illustrate how to build each type of component. There's also a PDF document that you'll find there that outlines the use of the API, and that's a super handy reference to keep close by. The Java doc is a browser-based documentation. So you open up the index.html document, and it outlines all of the properties and methods and so forth for the various classes in all the packages within the API. And also, if you find you're in need of implementing server control on directly on the server from server-side administration, there is a REST admin API that you can leverage and to do things like manage inputs and outputs and starting and stopping them, publishing services and exporting your configuration and so forth. Virtually anything that you might do with the browser-based GeoEvent Manager application, you can also do programmatically through the REST admin API. All right, so I'm going to switch over to my browser now and we'll have a look at GeoEvent Manager and setting up a real-time workflow, a real-time stream of data. What we're looking at here is GeoEvent Manager. This is the browser-based manager application that you'll use for most of your interactions with GeoEvent Server. On the monitor page, it shows me all the current GeoEvent services and inputs and outputs that I've configured, their current status, and gives us some tools to start and stop and see what kind of statistics they're producing. There are also additional pages where I can create new inputs and outputs and hook them together with GeoEvent Services, which we'll look at in a second. But I also want to show you that some of the other aspects of the manager here. For example, the GeoEvent definitions are the set of schemas that GeoEvent Server currently knows about. Every GeoEvent message that propagates through GeoEvent Server will conform to one of these schemas, and you can create new GeoEvent definitions, or GeoEvent Server can create them automatically in many cases. But each one of these messages, or correction, each one of these GeoEvent definitions simply indicates the set of fields that are part of a GeoEvent message that conforms to this definition. And we see a list of the fields along with their data type, and then a few additional tags. So in this particular GeoEvent definition, we have a field called device ID of type string. And because the track ID tag is there, it tells GeoEvent Server that this field contains the unique value for each track within the stream of messages. Similarly, it has a timestamp field of type date, and it has a time start tag that tells GeoEvent Server that this is the time field it should use. And down here at the bottom, we have geometry of type geometry, and the tag tells GeoEvent Server that that's the geometry field. And this is important because GeoEvent definition can have, unlike an ArcGIS feature service, can have multiple geometry fields. It can also have multiple timestamp fields, but the tag tells GeoEvent Server which one of those is the field that it should use in processing. So we'll also look at the connectors. And here you see a list of all of the currently configured inbound and outbound connectors that you can use to configure inputs and outputs within GeoEvent Server. This is where you'd go to create a new connector by pairing an existing transport with an existing adapter. And each one of these is already a combination of an existing transport and an existing adapter. But back in our services monitor page, we'll start to set up this workflow. So what I want to do is set up an input that polls an external website periodically for information, and I want to connect it to an output that produces a stream service. And Morakot talked a little bit about the stream services. Those are give us a lot of advantages in writing applications that leverage real-time data. Now, the external website that I want to use is this one. This is a website that provides the current location of the International Space Station. And if I notice that the timestamp and the latitude and longitude values will change if I refresh the page, and these values are updated about once every second. So the key values here that I am interested in, of course, the ID value, but also the latitude and longitude. You notice that it also has an altitude field, but this is given in kilometers, and we'd rather use meters, so we're going to have to do a little bit of conversion on the data before we can leverage that value. But then also the timestamp. You notice this is an integer. It's a 10-digit integer indicating number of seconds that have elapsed since midnight of January 1st, 1970, which is commonly called Unix time or epoch time. So it's the URL is the address, the key bit of information that I need from that page. And I'm going to come back to GeoEvent Monitor and switch my Inputs tab and create a new input. And these are all the input connectors that are currently configured on the machine. I'm going to choose the connector to pull an external website for JSON. And I'll just call this ISS input. And I'll paste in the URL that I just copied from that other website. Now, as I mentioned before, we can have a GeoEvent Server infer the GeoEvent definition we wish to use. So I'll have it do that from the incoming JSON values that it fetches from that website. I want to make sure that it polls that website once every second. And I also wanted to use the incoming latitude and longitude values to create a geometry field that's part of the new GeoEvent definition that it will generate. So I'll use the longitude value and for the X value and the latitude value of the incoming JSON, and I'll ignore the Z value because I don't want it to use those kilometers. We'll take care of that in a little bit. And I'll save this and go back to my monitor page. We'll see that ISS input was created and it's receiving about a point a second, so that's good. If I go to the Site tab then and take a look at the GeoEvent definition that was created, ISS definition, And it looks like it did a pretty good job of inferring the schema, except that the ID field is a double, and I probably like to change that to an integer. It's not. I could change it to string as well. It doesn't really matter, or I could even leave it double. What is important is that I give it that track ID tag. Also, the timestamp field, it inferred as a double value, so I'll change that to date, which allows me to choose a time start as a tag for that field. And we see that it did create the geometry field and gave it the appropriate tag, so I'll go ahead and save that. And go back to my services monitor page to make sure that it's still receiving data about once every second, so that gives me a good sanity check that I didn't break something by making some erroneous change in the GeoEvent definition. All right, so now I've got the input data coming in. I want to generate the output now, and then I'll be able to connect them in a GeoEvent service. So on my Outputs tab, I can add a new output, and oh, looks like I have one error state down there, but that's okay. I'll search the existing configured output connectors for the one that allows me to send features to a stream service. And I'll call this ISS output. Now, stream services actually exist on ArcGIS Server, so I'll choose the ArcGIS Server connection. This happens to be the same ArcGIS Server that this GeoEvent Server is running on. And that will show me the list of existing stream services that are part of that server. And none of those will fit my requirements, so I'll publish a new stream service. It'll give it the same name by default as my GeoEvent output that I'm configuring. And I want to make sure that when it creates that, it uses the ISS definition to generate the schema for that output stream service. A display field will be the name, and when I click publish, it's reaching out into ArcGIS Server now and creating that new stream service. And all I have to do in GeoEvent Server then is click save, and that saves this output. And so I have this down here as ISS output. And if I switch over to ArcGIS Server and refresh my page, I'll see that I have a new service here called ISS output. It's a stream service. And if I go to the REST services directory and refresh that page, I also have an ISS output there, which I can take a look at and verify that it has the right schema, and it looks like it does. So from that standpoint, it looks like we're in good shape. Back in GeoEvent, in the services GeoEvent Manager, I'm sorry, I can go ahead and create a new service to connect that input with the output, and so that I have some output, some data coming off that stream service, and then we can leverage that in an application. So this is the services authoring environment that will allow me to drag an input onto my my canvas and then an output. And all I need to do is connect them and publish this. And I watch the counters. Hopefully they'll start to increment, and looks like they are. And that's a great sign that data is flowing. And if I go back to my REST services page to my ISS output, I can view that information on a JavaScript map or click subscribe. And this is taking this client application and sending a subscribe request to my server. And hopefully we'll receive some information back. And of course I'm not. All right. Not really a good sign, but that's okay. We'll refresh this and wonder if we got some error on my server here. Oh, that's why. So the services crashed. Well, that's not very helpful. But at any rate, the this was the process that was required to set up a flow of data in GeoEvent Server. And so now that I have an input and an output and a service configured, I can go back to my my development environment and start to write applications that consume that data. So let's take a look at what's required in order to be able to do that. As Morcott mentioned, there are a number of different APIs within the ArcGIS environment that you can leverage to build real-time applications. For this presentation, we'll use the JavaScript API, and the ArcGIS API for JavaScript comes in two versions, version 3 and version 4. And for our purposes, they're by and large the same. If you're going to build 3D applications, you'll need to use JavaScript 4, but our application is actually a 2D application, so we could really use either one. In either case, we need to start by adding the Dojo require statements to our script, and then within the script itself, we'll have a map, and we'll have to define a new stream layer and pass it in the URL to our stream service. And that really is all that's required, and we simply need to add the stream layer to the map as a new layer. And the process is by and large the same with version 4 as well. We add the Dojo require statements, and we create a new stream layer and add that to the map. Now the difference with version 4 is that there's also a map view that you need to add, and then add the map to the map view. But in terms of creating the stream layer, the process is the same. There are some additional properties that's good to know about with the stream layer, and they're not required. The only one that is required is the URL to the stream service. But the purge options allow you to control the display of features on the map and the lifetime. And you can purge features based on the number of features by setting a maximum threshold of features to display on the map, as well as the age. And features that are older than the purge options age property that you set will be removed from the map. By default, there is no maximum, so they won't ever be removed from the map unless you clear them by some other means. There's also a maximum track points property, and this is going to be specific to each track. So if you have a stream service that's producing 12 discrete tracks or following 12 moving objects, let's say, the maximum features per track ID is set with this property, and by default it's 1, so it'll only show the most recent observation for each one of those tracks, but you could set it to any other value, and it'll maintain that number of observations on your screen. And this is how you get a little breadcrumb trail following behind a moving object, for example. Now there's also a purge interval property that you can set, and this simply tells the stream layer how often it should go through and purge expired GeoEvents and expired messages, features that are in your display. Now the GeoEvent definition that we set up for the International Space Station data didn't include a time end field, but as I mentioned, a definition can have multiple time fields, and they be marked as time start and time end. So if features coming from your stream service have a time end field, your stream layer will honor that, and it will purge expired features from the display according to the time end value. A couple other properties that it's very good to be familiar with is the definition expression, which allows you to set a where clause on the subscription request that your client makes to the stream service. This allows you to say that you only want the server to send you features that meet a certain set of a certain condition. And so you can set that definition expression on your client, and then the server will honor that. Similarly, the geometry definition allows you to send in an extent along with this subscription request. And even though the server might be capable of sending features that cover the globe, if you're only interested in one specific area, this is a way to get the server to reduce the amount of data traffic that it's sending to your client application. All right, so I'm going to once again switch back over to my text editor here, and this is a very simple JavaScript program. It's HTML and JavaScript inline. And if I go over here and I'll go ahead and run this, I'll open this up in a web browser. It's a simple interactive mapping application. It allows me to zoom in and out and pan around, and but not much else. So what we want to do is add in some real-time data. Now, this is going to be a fairly short course. If all right, it looks like the service is back up. Let's see if well, it's not. Looks like it's not producing here. ISS service. Let's start that. Make sure things. There we go. That's much better. Much better. All right. So hopefully that'll stay up long enough for me to make use of this. All right. So in my stream layer, or in my JavaScript application, I want to use the address of this output service, and I'm going to use that URL over here in my JavaScript application. So the first thing I'll do is add my Dojo require statement. Esri that, whoops, make sure that's inside the double quote. And I'll make sure that add it here. All right, so I have a map and a map view. So all I need to do now is add a stream layer. And remember, the only required parameter that I need to send here is the URL. So I'll paste in the URL to the stream server, and then the last thing I need to do is add that as a the stream layer to my map, and that's it. So I'll save that and go ahead and run this again. And there it is, just over Western India. I'm getting about an update a second. All right, great. And we can experiment with some of those other properties, such as the maximum track points property. Set that to be 5, and we'll save that and refresh our map here. Wonder if the service went down again. Well, anyway, if the service went down, then looks like we might not see the International Space Station again today. But at any rate, we can see some of the oh, there it is. It came back finally. So the service is kind of flaky today, apparently. But there are a number of other applications that you can have a look at, and I'll show you many of these here. And I'll also provide shortcuts to the to many of these applications here in the slides, so that you can access these. But we have sample applications on GitHub that you can download and experiment with, along with a number of sample stream services that you can use for your in order to learn how to use real-time data in your applications. And then there's also a lot of documentation on the JavaScript API, as well as some tutorials and discussions and blogs on GeoNet that you might benefit from. So let me switch back over to my browser here, and we'll take a look at some of those. I don't know that we can see all of them with the time that we have left, but there are GitHub repos for JavaScript 3 and JavaScript 4 applications that you can download and experiment with. There are also some non-JavaScript applications, such as this one. This was created with the ArcGIS Runtime SDK for .NET and WPF. And Morcott, I think you know a little bit more about this application than I do, as a matter of fact. You have anything to add?
Yeah, this is it was created from the runtime. I believe it's using Xamarin, and the runtime SDK may not support stream service from the API, but it does support a WebSocket, which is part of the stream service. So you can use one of these SDK to connect to WebSocket and still receive data from GeoEvent.
Cool, thank you. Another example of a non-JavaScript application here is this flight sensor demo. This was put together to leverage Raspberry Pi to receive flight information updates over the air like this. So there's you see a picture of that component there.
Yeah, the blue USB stick is like $30 and can receive real-time flight data in the 200-mile radius.
Very nice.
Yeah.
A couple other applications that you might be interested in. This dashboard shows the current locations of some vehicles in and around the city of Baltimore. Here's another real-time dashboard that shows vehicle locations, snowplow locations in Salt Lake City, Utah. All right. So
do you have the 3D? Yeah. Okay. Here's the one. Yeah.
There we go. Yeah. This is a pretty neat little application. This was created using 3.js libraries in JavaScript, and this also continues our theme of the International Space Station. But this shows us the current location of the ISS as well as the breadcrumb trail. But the space station is rendered in using this nice 3D model. So it's kind of a clever little application.
Yeah, the breadcrumb trail that you try to show right in your 2D. So this is the effect of doing
exactly.
That.
Mm-hmm. Let's see. This is a great example as well. I'll zoom into where it gets interesting. There we go. So you can see this aircraft is rendered in 3D, and this video shows what was at the time a real-time application of this data, this aircraft location data, and you can see that there are a number of aircraft that were part of this stream that was captured.
Yep. So this was JavaScript version 4, and used the 3JS API. It's kind of similar to the space station that you show in 3D. Yeah. And we can read the full 3D models into the scene, and then the aircraft position updated from data stream coming from GeoEvent.
Thank you, Morcott. So that's a lot of other applications I could show, but that's really about all the time that we have today. And I want to make sure that we leave enough time for questions. Amy, how should we handle the questions?
Thank you, Ken. We're now going to begin answering the questions submitted during today's presentation. We've received quite a few, and we will try to get through as many as possible, but whatever we do not get to today, we will address in a GeoNet blog post after this webinar. As a reminder, you can still submit questions through the questions pane in your attendee control panel. Our first question is GeoEvent Server only a component of ArcGIS Enterprise?
Yes, that's a great question. It is a component of ArcGIS Server, which is part of ArcGIS Enterprise, and as such, more specifically, it requires ArcGIS Server to be installed. Now there are some licensing considerations where people who previously had ArcGIS Server before we went to the enterprise model can continue to leverage ArcGIS Server that way. But our current approach to distributing ArcGIS is through the enterprise model, and so you could look at it as not a technical dependency on ArcGIS Enterprise, but it is the way we distribute GeoEvent Server along with ArcGIS Server.
Perfect. Next question. Must data be loaded into the spatiotemporal big data store, or can data for GeoEvent Server be loaded into an RDBMS?
Oh, excellent question.
Right.
Yeah, go ahead, Morkat. Go ahead.
Yeah, I think I probably addressed some of those during my part. It can go into either one, right? It's your choice. If you have a slow data feed coming in, I would say less than a few hundred events per second, you can choose to use relational database, typical geodatabase, backed by Oracle, DB2, SQL Server, Postgres, one of those flavor. But if the incoming data is high speed, high velocity, more than a few hundred events per second, I would strongly suggest to choose to use the spatial temporal big data, because if you try to use the traditional database, you will have problem of so-called back pressure, and it will result in message dropping and losing data from the incoming. Yeah.
Okay, great. Thank you. Can GeoEvent Server outputs be configured and saved in a specific folder on ArcGIS Server?
Yeah, that's a good question. No, as a matter of fact, the inputs, outputs, all your components are you find them in GeoEvent Manager. They're not things that get saved as files, so that there's not really something that you can configure and store in ArcGIS Server. Like I mentioned, the ArcGIS GeoEvent Manager is the application that you'll use for just about all of your interaction with GeoEvent Server and its components.
Right. Well, I like to add to that. Actually, some of the output from GeoEvent can be written to a file like CSV or JSON, but it will reside on the GeoEvent machines. Right. We have some application like desktop application that ship with GeoEvent that call I believe it's GeoEvent Data Locker, something like that. That one is a TCP client application that you can connect from a remote machine to the GeoEvent machine to TCP, and then you can choose to log to your local machine using that application.
Great, thank you so much. Are stream services preferred over feature services? Is that an extra cost or just another option?
Right, Ken?
Yeah, the stream services are just a capability of the platform. There is no additional cost required to implement that.
All right. Can I use GeoEvent Server with the ArcGIS Indoors product and create my own SCADA system with it?
Good question.
More familiar? Yeah, yes. Yeah. There seem to be two questions here. Did I hear indoors product? Yeah, if it's indoors, yeah, I would address that first. The recent technologies advancement in indoor positioning especially by Apple has enabled indoor position, and we have application that being developed to receive indoor position where you are in the buildings, what floor, and then you can send that information to GeoEvent. Yes. Did I hear SCADA as well?
Yes,
Amy?
it was. Yes, it was both indoors and SCADA. Mm-hmm.
Yeah. So there are a number of, especially utilities company that implement SCADA. So the SCADA is data that coming from gauges and valve and some other thing like water pressure, could be electric current, that sort of thing. The measurement are done in analog and then converted to digital, right? Then sent to some server somewhere, data collection point, and that can be streamed into GeoEvent as well. We have partners like OSI Soft that implement the SCADA solutions, so it can receive data from, for example, your electrical providers. You need to make sure that everything is working and there's no outage, right? So that data coming through SCADA and then going into GeoEvent and then could give some sort of warning and triggers, and so save to big data store so that you can do some predictive analytics. You can see that when is the peak hour that people consume more electrical, and other thing, and then you can prepare your system to take the load. Yeah.
All right, thank you. Why are stream services unable to be symbolized in Portal based on an attribute?
They actually can be. Go ahead, Morikant.
Yeah. So this is the limitation in the web map implementation that doesn't provide any symbolization with stream layers. But from the developer point of view, you can choose any one of those renderer that are available from our API, any symbols to symbolize the stream, the data coming from stream service becoming stream layer, right? So you can symbolize the most current positions, and then the breadcrumb with different symbol, and you can symbolize different track, different object with different symbology as well. You want to add something, Ken?
No, that was the exact point I was going to make, is that you can, as from a, if you have the technical and developer chops, you can go in and modify the the surface definition to provide the renderer that you want on a stream service.
Yeah, you can also do that. Yep.
Yeah, exactly.
All right, thank you. Can feature services use the spatiotemporal big data store as its source, or must those services only be hosted or stored in a traditional enterprise geodatabase?
I'm trying to understand the question. So I hear the keyword source. So I'm not sure if the question about that will be a source for GeoEvent. And if that was a question, then I would say yes. Yeah. There's some application that first stream data into the backend geodatabase or Oracle or anything like that. It doesn't come directly to GeoEvent. Could be limitation from the data source implementer, right? Some of those S3 application like collector or survey 123 does the same. It first put the data into backend relational database or even ArcGIS Online. But doing that would not allow to do some sort of real-time analytics like geofencing or alerting on attribute. So GeoEvent can pull from those feature services, and then you can create real-time analytics and do geofencing or attribute alerting in GeoEvent. So we support that pattern as well.
All right, and our last question, can GeoEvent Server be used with operational dashboard?
Oh, sure. Well, as Morikant mentioned, GeoEvent Server doesn't have any sort of visualization capability. So you'd need to use operations dashboard or some other application to receive that data. That being said, if you wanted to leverage stream services, those generally go into a map, and then you use that map in operations dashboard. So if the map is receiving real-time data, then your operations dashboard will display real-time data, and it's really as simple as that.
Right. I like to add that the development on the operation dashboard, especially on the JavaScript versions, is ongoing, and then they're increasing support for service stream layers. So they already support stream layer now, and I think the next phase is to support the rendering, because this is the most request feature function for the dashboard, right? So look for the near future release coming out. Yeah.
All right, perfect. Thank you, Ken and Morikant, and thank you everyone for attending today's webinar, Real-Time GIS, Mapping and Analytics. On behalf of Esri and our presenters, thank you for joining us today, and have a great rest of your day.